All right, this is going to be a short video on conversions and dimensional analysis. So first off, conversion factors are simply just a ratio of equivalent measurements. So we can think about this when we say that there's 12 of something in a dozen. All right, we have 12 bananas are a dozen, or 12 eggs is a dozen. So if we said we have 36 eggs, how many dozen do we have? You'd say 3. All right. And although that might seem like a small thing, what you've actually done is dimensional analysis. You've said that 1 dozen is equal to 12 eggs, and then 36 divided by 12 is 3. Well, we're going to learn how to actually set this up in an easy to work, really not formula, but process. So when we have that conversion, it's the ratio of equivalent measurements, and so we'll get into the metric of it, like 1 meter is 1,000 millimeters, or 100 centimeters is a meter. Okay, a conversion factor has 3 things about it. The unit, when we use one, the unit's always going to change. So we changed from individual eggs to dozens, or from meters to millimeters, or liters to kiloliters. We're changing the unit. The value almost always changes. Sometimes we have a unit which is equivalent, like milliliters to cubic centimeters. This is a 1-to-1 conversion. So if you had 10 milliliters, you'd also have 10 centimeters cubed. But almost always the value is going to change. But the quantity we're talking about does not change. They are equivalent measurements. So if we had 36 eggs or 3 dozen eggs, we're still talking about the same quantity of eggs. We're just representing it in a different way. So conversion factors are perfect. They're going to have unlimited sig figs, which means that when we're doing any calculation with significant figures, you can just count this out. It does not impact sig figs as they are infinite. If we haven't got into sig figs yet, we will. So when we have the metric system, which is kind of the heart of what we're going to convert here, and the easiest way to explain dimensional analysis, we remember our prefixes with the King Henry died by drinking chocolate milk, right? Which is the kilo, hecta, deca, base, deci, centi, milli. And in grade school, we may have learned that we're just going to slide that decimal over one spot every time. So as you go from kilo to hecto, just slide it over one. Hecto to deca, slide it over one. But the problem with that is when we start to get to these advanced units, it doesn't work so well. And so what we're going to use is dimensional analysis. We are, however, going to think of this chart. And I want you to think about it in this way, with the kilo being up top, milli being down at the bottom. I want you to think about it this height-wise. Kilo, hecta, deca, base, deci, centi, milli. All right, so we have this. So if we look at conversions, let's go ahead and do this dimensional analysis. So we want to convert 34.7 milligrams to decigrams. All right, now, when we do dimensional analysis, the first thing we're going to do is we're going to start this chart, okay, which is really just a cross, okay? So you can write it out, draw a line down. Now, how this thing works is you're going to put measurements on each spot. I'm going to show you in a second, but then you multiply anything across the top, or you multiply anything across the bottom, and then this acts like a giant fraction sign. You divide the top by the bottom, okay? Now, how we use this is fairly simple. Whatever we're given, in this case, 34.7 milligrams, is going to go in the top left every time. All right, so 34.7 milligrams, the given. Now, whatever unit, all right, whatever unit is top left, in this case, milligrams, and you're going to hear me say this a lot during dimensional analysis, whatever unit is top left also has to go bottom right, okay? So if we're in milligrams on the top left, we need to be in milligrams on the bottom right. Now we're not going to put any numbers in, just the units on the right-hand side right now. So milligrams is top left, milligrams goes bottom right. And then the top is whatever we're converting to, in this case, decigrams. Okay? And so now we're set up. We just have to insert numbers, but we're going to convert. Since you're dividing the top by the bottom, these two things are going to end up canceling out whenever we do the math. And we'll be left in this unit, okay? So now, when we're doing the metric system, okay, and in anything else, you could just use whatever the conversion factor is. So if this was, eggs to dozens, well, next to dozen, you'd put a 1, and next to eggs, you'd put a 12. But we're not. We're doing decigrams to milligrams. Well, now it comes back to our chart here of King Henry died by drinking chocolate milk. And we got to remember that this is deca, DA, where that's deci. And so what you do is you look at these things and you say, which is higher on our chart? Which is higher? And what ultimately happens is deci is higher than milli. Deci's up here, milli's down here. Whichever one's higher gets the 1. So because deci's higher on our chart, you put a 1 next to it. Now, next to the other one, you're going to have some multiple of 10, depending on how many times you have to go up. So every time you go up, you're going to do one multiple of 10. So from milli to deci, you go up once, that's 10. Twice, that's 100. And so we put in here a 100. All right. If you were going to go up higher from milli, so it would be 10, 100, 1,000, 10,000, you keep going. And now you just solve, right? As we said, milligrams is top and bottom, so it cancels out. 34.7 times 1 divided by 100, 0.347 decigrams. Okay? That being our final answer. So now let's do the one down at the bottom. Again, we make our cross with our given is always going to go on the top left, 0.5942 kilograms. You have to put the units down because you would never know what to put here. Whatever unit's top left has to go bottom right. So kilogram is going to go bottom right. And wherever we're trying to convert to is going to go top right. So now we have our decigrams. So now we have to ask ourselves, well, what's higher, deca or kilo? Let's look. Well, milli, centi, deci, base, deca. There's deca. Hectokilo. Kilo's higher, so that gets the 1. All right? It doesn't matter which is on top, which is on bottom. Whichever one of these prefixes is higher on our chart, that's going to get the 1. And now we need to know, well, how much does it go up? Well, from deca to hecto is 10, hecto to kilo, 100. We go up twice, so it's 100. All right? And again, if we were to go up again, then it'd be 1,000. Again, after that, 10,000. And now we just do the math. Kilograms top and bottom, so that unit cancels out. We now know that we're in decigram, 0.5942 times 100 divided by 1, and we get 59.42 decigrams. All right, easy dimensional analysis. All right, so now it comes into, that's the easy stuff with just our simple metric system, just the main prefixes, okay? But that's really not where we're going to stop, not at our level. We're going to have some more prefixes. So we're going to get into stuff like mega, giga, nano, micro, these things that are above and below, okay? But it's not going to give us every 10 anymore. And so when we're in these big jumps, okay, which is above our King Henry died, okay, those prefixes, we're going to go in a factor of 3, okay? So we can think about this in terms of data on our phone. When we go from megabytes to gigabytes, it's a factor of 3 or 1,000, right? 10 to the third. So when we go, if you have, cell phone use, every 1,000 megabytes is a gigabyte, right? Which is 10 to the third. And the same thing when we do giga to tera. It's 1,000 or 10 to the third. So when we have these prefixes, guys, that's what it is. Pico to nano, 10 to the third. Nano to micro, 10 to the third. Micro to milli, 10 to the third, right? The same with milli to the base. The same with base to kilo, right? There's 1,000 meters in a kilometer, okay? So all of these work on a factor of 10 to the third, all right? And you're just going to have to learn these prefixes and where they fall. All right, so let's take a look at doing one with dimensional analysis. So we're going to take a look at this example right here, okay? So nanometers to meters. Again, we make our chart. And we start with 526.9 nanometers. In which case, since nanometers is top left, nanometers is going to go bottom right, and we're trying to go to meters, so meters will go up top. Now in this one, again, you're going to have to just kind of learn it, but really what we had was that nano went to micro, which went to milli, which went to the base, which went to kilo, and then to mega, and then giga, right? And those were our main ones. So when we're going from nano to meter, we're going to go up 1, 2, 3 times. But remember, each one is a factor of 1,000 or 10 to the third. So one jump, 10 to the third, another jump, 10 to the sixth, another jump, 10 to the ninth. All right. But what you have to ask is which one of these is higher? Well, meter is the base, nano is there, so meter is going to be higher. You put a 1 next to meter. And then you're at nanometers. So again, 3, 6, 9. So this will be 10 to the ninth. All right, and when you convert that, nanometers cancel out. 526.9 times 1 divided by 10 to the ninth, and we come out with 5.269 times 10 to the negative 7 meters. Okay. All right, last example here. We're at the other end, the giga. So we start off with what we're given, 1.024 gigaliters, which means that gigaliters are going to go on the bottom and the liters is on top. So you say, well, which is higher? Liters is the base unit. Gig is up here. So clearly gig is higher, and we're going to put a 1 next to it. So now we say, well, how much higher? Well, base to kilo, that's 10 to the third. Kilo to mega, 10 to the sixth. Mega to giga, 10 to the 9. So we're using 10 to the 9 again. All right. But this time we're going to multiply across the top and divide by the bottom. 1.024 times 10 to the 9th. This is an easy one because we'll just leave it just like that. 1.024 times 10 to the 9th and liters. All right, and that's dimensional analysis. Real quick, real simple, real straightforward.